Awesome. Before we get started with the questions, Amog, do you want to, first of all, I
Yep,
am
it's
pronouncing
Amogh.
that correct, right? Perfect. Amog, would you like to introduce yourself real quick?
Sure, I'll give a quick intro. My name is Amogh Patankar. I'm currently a research engineer at Hydra, where I'm working on AI inference for video and visual communication. Before I joined Hydra, I was at UC San Diego, where I finished up my undergraduate and graduate degrees in data science and computer science with an AI/ML specialization. So yeah, excited to be on, excited to talk to you.
Awesome. Yeah, thank you so much. So again, just for context for those who are watching, we've prepared a set of 7 questions, and we'll go through those sequentially. I'll start off with the first one, which is, what, in your opinion, is the difference between working as a research engineer specifically? A distinction between those two roles. Are they similar? How similar are they? And specifically, on a day-to-day basis, is there a lot of theoretical or research-oriented work that you do, like reading
Yeah, I
papers,
think I'll
replicating
preface my
methods, and
answer
so on
first
and
by
so forth?
saying that I think inherently the definitions of research engineer and ML engineer, they vary from company to company, from person to person, right? So anyone can define them however they want. In my eyes, it's actually there's a spectrum, right? So you have research scientists on one end, you have MLE on the other end, and so research scientists are responsible for pure research. So you read papers, you're at the forefront of whatever industry or domain you're in. They're going to be the researchers who write papers, read papers, evaluate some state-of-the-art methods, and then experiment in sandboxes, not necessarily in production environments. MLEs in the opposite end of the spectrum are responsible for implementing these ideas. So you productionize and scale systems or models or algorithms. So research engineers fall right in the middle. And so they're a bridge between the two. So they, or we rather, read papers at a high level. Then you collaborate with research scientists to take their sandboxed experiments and implement them within a system or within a project. And then essentially, as you prototype these ideas, you prototype them at a broader scale and you turn research papers into working code. And in AI, where you traditionally see research engineers, it's done in some high performance computing environment like Slurm or on some Oracle cluster. And so then research engineers work with MLEs to focus on taking this working code and working experiments and then focus on efficiency and scalability. So I'd say for, a research engineer, maybe 10 to 20% is reading papers. I'd say about 10 to 20% is implementing these things and scaling. And then the rest of it is just implementing ideas and performing different experiments, optimizing different things, and then working with MLEs to actually productionize it.
Awesome. Yeah, and this might be just for, like, my personal curiosity, but I'm sure there is someone listening to this out there who would also benefit from this. But how much of your work would you say is it like mathematical in nature? Because and this is actually a question that we will get to later, but oftentimes people, I think one big thing I've noticed personally is that people underestimate the mathematical aspect of machine learning, when in reality it's basically all just linear algebra that is going on, and other advanced mathematical methods, of course. So
Yep.
how mathematical inherently is the work that you do?
I think the theory or research aspect of it is extremely mathematical. So these papers that are at the forefront of the industry, like you said, the basics of machine learning are just linear algebra and pure math, right? So even, techniques like gradient descent, stochastic gradient descent, all the way up to some of the state-of-the-art stuff, for example, in language modeling and in video modeling with diffusion transformers, it's all just mathematics. And so at the end of the day, you need to have a strong foundation in math that can either be done through, undergraduate programs or graduate school or some research. But yeah, at the end of the day, it's all mathematics. It's just what level of complexity is that mathematics at? Yeah, and so I'd say for me, when you read a paper, you're going to be reading through the math, right? Specifically the math and the implementation. And how did they translate that math to directly to code? I'd say MLEs focus more on the actual productionizing or productionization of, an experiment or something that's running. And so maybe for MLEs, it's a little less mathematical or a little less, math involved. For research scientists, I could argue it's almost purely math, where you have to understand what these researchers have put out in this paper. For me, I think it just depends on the stage of the project that you're in. I think initially it's pretty math heavy, and then you begin experimentation and actually coding stuff up. And then sometimes, you notice, hey, this feature could be improved with this new paper. So you go back, take a look at what the person's done in the paper and implement it. So I'd say, it varies from time to time and also just role to role.
I see. Yeah, and I think that's a pretty good segue into the next question, which is how well did courses at UCSD prepare you for the work that you do? And I think, put another way, um, like on a daily basis, how much of what you learned do you directly put to use in like how much of what you learned in courses at UCSD do you directly put to use? And if not courses, what other avenues, opportunities at SD would you say is beneficial for students to explore in order for them to better their chances of working in a role that has similar responsibilities to the role that you currently have?
Yeah, I guess I'll start off by saying this. I did my undergraduate and graduate program at UC San Diego, so maybe I'm a little bit biased inherently. I'd say UCSD prepped me pretty well in a variety of different aspects, right? So for context, my job spans across, model training, model inference. I've been doing some data stuff on the data side. Nowadays, I'm doing more agentic work. And so I think I'd say my UCSD, for example, my data science degree, I think it taught me a lot about data systems and how to manage data at a very, very large scale. I think my graduate degree and the coursework that I did there also contributed pretty significantly. I'd say, the things that I directly put on use to data on a day-to-day basis, I'd say, 60 to 70% of it is what I've learned over a course of 4 to 5 years in undergrad and, my grad program. Specific to my role, maybe as a research engineer, I think specific courses stand out, right? So, for example, CSE 234, which is data systems for ML. When I took it with Hao Zhang, it turned into an LLM systems course, which, he's at the forefront of his respective domain. I think so, courses like that, courses like data systems and data management, more traditional deep learning courses like CSE 150 on B with RoseU, those are the kinds of courses that really help me be prepared for the most part for my job. I think outside of coursework, there's a bunch of different avenues or opportunities at UCSD. I think, these clubs, for example, Data Science Student Society, where you have these project teams that are constantly working on AI projects in different realms, right? I think when I was in undergrad, I did a project on using deep learning to predict the shot completion percentage for an NBA player. I know in some of my courses, I've done deep learning for trajectory prediction for autonomous vehicles. And so these kinds of different, projects at a club like DS3. There's hackathons, for example, DS3 hosts a hackathon. These various different clubs have hackathons, they have tech talks, they have technical workshops. So I think these things help you stay in touch with a lot of these concepts after you finish up coursework in a more practical and application heavy method. I think, again, all these things aside, of course, I've done some internships which have helped me transfer some of the skills from my coursework to production environments, which then obviously transferred over to my current job. So I think, it's a mix of these three or four different things.
I think, another question that I had that was also related to both of these things that we discussed, is the whole conception of like, working at a company as a research engineer, because to me, at least, when you say the word company, right, that implies that there's a product or service that somebody's trying to get out there. But research, especially academic research, I'm not exactly sure what research at a company would look like, but all of that has to be geared towards creating a product or bettering a product that currently exists. So I was wondering, is there like is at a high level, how does one um basically unite these two worlds, one of academic research and the other one of designing a product, imping of that sort? So how are those two united?
Yeah, I think I'll start with, kind of talking about what my company does and what, research that I'm doing contributes to a product wise, right? So for context, Hedra, we have, a studio, a creative studio where you can generate images, you can generate audio, and then synthesize those to create video and, create marketing content, sales content, whatever it might be, right? So the core of that platform, obviously, as you could tell from what I said, is synthesizing things into a video. So I can take a text and an image and generate a video from it. And it will have audio because our model supports audio conditioning. Or, alternatively, I could take an audio, a text, and an image and generate a video. And so that's the product aspect, right? So we put this product and, it's inside of our creative studio, and that's available if you just create an account and decide to use it. behind the scenes, right, on the back end, though, how does that model work, right? We host it on Together AI, which is our, cloud compute platform, and we have our weights stored there, and these weights obviously have been trained, and that's kind of where the research aspect kicks in, where okay, we have this model, we're continuously improving it with new state-of-the-art techniques, and once we do this research, research scientists in our company, they do pure research, they do some experiments. Research engineers like myself and a couple of my colleagues, we take these experiments, scale them up, make sure that they're working efficiently and they'll scale even higher. And then we pass it along to MLEs or, deployment engineers who make sure that this research and model that we've built out is actually able to be used by the masses or the people who actually use our product or our platform. So I think, that's my company and my um, synthesis of product and research. But I think that's the case, with a lot of different companies and even as a student, right? So let's say you're doing research in a research lab, and that's, pretty theoretical. You're doing some experiments, and you'll publish a paper potentially. And one thing that I found that a lot of people are doing nowadays is while they're working in a lab, they're actually able to build around whatever research they're doing. For example, if someone's doing research in, reasoning for LLMs, right? So what they might do is take, some open source weights for a language model. They might host it locally and then try to use those techniques and actually build an app around it, right? And, nowadays with the introduction of Cursor and Claude Code and all these AI tools, building a website or building an app is not as time consuming as it was, a year ago, 2 years ago. I've seen people on Twitter who have done it in, 2 weeks, 1 week. And so, that's kind of the mixture of research and product at a high level.
I see. Yeah, that's actually very insightful because that has always been something that has confused me is that again with regards to my personal experience, I'm a math major, so I just do stuff on the theory side, but my favorite aspect of that is essentially using stuff like like earlier you mentioned stochastic gradient descent, right? Using that, studying the theory behind that, and developing numerical methods that can maybe improve those sorts of things, especially in biological contexts, which I find really fascinating.
Yeah.
So something that has always made me, it has always interested me, has been, given that there's a research background for that, how can I transform that into a product that can, like help people essentially, or deliver a certain service for another party that is perhaps designing a product of some sort. But yeah, that's very insightful because I think that is the hardest part. Like on one end, you have academic research, and on the other end, you have like production
Yep.
of something extremely insightful. Again, I of course I can't just ask you questions that I'm curious about.
Sure.
A lot of our audience is going to like to hear or hear your input on, which is how much did networking help you land your current role? And do you have any tips on how to make and utilize connections properly, and any underrated tips that you might have used that others haven't or people typically don't talk about?
Yeah, the reason I'm smiling when you ask this question is because ironically, networking actually did not help me at all when I landed this specific job. This specific role I just landed by, I cold applied to the company through LinkedIn, and I wrote a very, very seems like a very, very compelling cover letter and sold myself to them through that. But I think broadly speaking, right, your question about, how can you make connections and how can these connections go from just, a one meeting to, hey, potentially you could help us build out a feature or you could join the company. I think it's interesting because I think making connections is a long-term process. And I think a lot of the times people are not aware of that or forget that, right? People think, okay, connections might just be, hey, like I met you today is, this is what I'm doing in my undergrad or grad program. I've interned here. Okay, cool. This is what you're doing at your company. Okay, you're building software for, note taking. It's like, okay, wow, this is really cool. And they leave it at that. I think, making connections, like I said, it's a long-term process. So you need to establish, the relationships over a period of time. And I think part of that can be, you need to talk to people frequently, right? One part of it is just frequency. So you can't just talk to a recruiter or an engineer or, an ex-colleague once or twice and then ask for a meaningful referral or a meaningful reference. Because at the end of the day, it's just like asking for a letter of recommendation, right? It's going to be very surface level and it might not actually help you as much as you think. I think, there's definitely some underrated aspects or underrated tips for networking. I mentioned one of them, which is frequency or how often you talk to these people. The second one is really like the kinds of conversations you're having, right? the people you're talking to need to be interested, and there needs to be actual nuance in your conversation. If I start talking to you about, oh, this coursework that I'm doing is good, I like it a lot, and I'm interested in machine learning, that won't draw you in as much as if I said, hey, I'm taking this math course and we're talking about stochastic gradient descent. And, there's this interesting paper that came out which approached it a different way, right? So I think that's a second, underrated nuance. And I think third, this is a wild card, but I've already kind of touched on it nowadays, right? If considering the speed at which people are iterating and building at, if you're able to do a project or if you're able to build some sort of app or interface and doing these interesting things that relate directly to this person you're talking to, for example, if you're talking to an engineer at a startup and you have an interesting feature that might actually be relevant to their platform or a feature that their company's product has, that helps immensely. And not saying that I did this, I think that's one of the things that I missed out on when I was an undergrad and graduate student. But these kinds of different underrated or unique aspects help a lot. And I think a lot of people might not necessarily be aware of that. And I think that's something that does come with experience, right? When you eventually do start full time and you start getting cold emails from people saying, hey, I built out X feature. I think it's interesting that, your company could use it. That's something that you would not necessarily think of as a student. And so I think these two or three things, are pretty underrated when it comes to that.
Yeah, that's actually really interesting because I was reading about very recently, actually, I was reading about a person who applied to a company, um, and their whole application was centered around the bugs that bothered them as a user,
Yep.
and how they would improve on that. So it's very interesting that you touched on the idea of having a certain feature, because that's also something I've seen not iterated, sorry, but like replicated and talked about elsewhere as well. Um, I'm going to dip back into something of my interest again, and I'm like sort of like bouncing in between the
Yeah,
two.
no, no worries.
But as an individual, if let's say we're working on a project, do you have any tips on how we can scale that project into something larger? And again, this is something of my interest, but I also think it would interest some of our viewers because, like you mentioned, if you have a project, one of the ways you could network with someone is asking them about the ways which you could
Yep.
scale, whether that be a feature or your own project, right? So I was wondering if you had.
Yeah, definitely. And it's really interesting that you asked this question. I was on campus yesterday, I think like Tanvi knows, and I gave an alumni spotlight, and one of the questions that a student had afterwards was exactly this. He was saying, I have this idea or this project that I'm working on, and me and granted, it was a group project, but it's the same concept. We had it, we think we have an interesting project, and I want people to be able to, interact with it, use it, give me feedback. How should I go about this? And I think the answer here is twofold, right? One is kind of your circle and your community. And what I mean by that is, you're a student at UC San Diego, and let's say you're building an app for fitness tracking. Well, okay, one thing you might do is, go to different events hosted by DS3, for example. Go to a hackathon. Reach out to different people that might be indirectly involved with the work you're doing. For example, if my fitness app involves recommending certain foods to me, well, the core technology behind that is recommender systems, right? And on campus at UCSD, I know because I've taken classes with him, Professor Macaulay is one of the most accomplished researchers in recommender systems. And so my advice is, talk to people who know about the core aspects of what you're working on. And then the second part, that's the first part, work with your community. I think the second part is a little scary, right? Admittedly, and I'll get into why. The second part is you need to build in public. And what I mean by that, of course, put your projects on your personal website or on your GitHub. I think the scary part is things like posting on LinkedIn, posting on Twitter, right? It does take a lot of guts and it does take a lot of courage to put yourself out there and say, like, to your audience, hey, I'm working on this, give me feedback or use it and tell me how it goes. There's communities on Twitter called Building in Public where people, individual developers, group developers, they're working on something and they want to show their community and they want to get feedback, they want people to test it, they want people to tell them where it went wrong. So I think these two different things, I guess, are my advice into how you take maybe a personal project or something small that you're working on and maybe grow and get some feedback on it.
Awesome. I think that was very insightful. And actually, in the same vein, again, this is not a part of the prepared set of questions, but I am taking a look and I'm seeing that perhaps it is a sub part of the earlier question I asked about being a research engineer. And it's in the same vein, which is um, you've worked at a variety of different, or worked with a variety of different things, essentially, different subject areas, topics, whatever you might call it. And to me, the most interesting thing was given this diverse, set of industries, and I would encourage our viewers to take a look at Amogh's LinkedIn because it really is very diverse. You go from biological research all the way up to finance and everything in between. So, what would you say unites your work experiences? I know that's probably like a very vague term, but specifically, what do you think is the common thread between all of these work experiences? And does it take a lot of learning before applying to said roles, or would you say it's more of an on-the-job type of thing? And the reason why I'm asking this in particular, I just want to give some context, is because, like I mentioned earlier, of course, you can take projects and you can scale them, but um, if your goal is to use those projects and put them on your resume, then perhaps it would be beneficial to align them to a certain field. For example, like if you're in bio, you would do a bio-oriented project or something of that sort. So that's just the, context behind this and how it relates to the earlier question. But yeah, I want to, throw it back to you. So what would you say is the balance between learning on the job and learning outside?
Yeah, I think, I mean, I'll go question by question maybe. I think, working in a diverse set of industries, all the way from biomedical research to software to, AI inference, it has its pros and cons, right? I think on one hand, having these various opportunities allowed me to solidify, in my mind, what was I interested in working on, or what domain or what industry did I want to work in, right? And I think the majority of, when it comes to preparation for these roles, like you mentioned, I think usually it's done through coursework or some prior experiences, right? For my first internship, you don't really have much experience in the professional setting. So it's going to be very heavy on, your preparation will be very much due to your coursework. And as you, gain more and more industry experience, you kind of build off of that. I think one unique aspect is just recognizing that, your role is what matters, and the industry is simply what dictates the application of it, right? For example, take a concept like regularization of machine learning models. Regularizing an ML model in a biotech setting versus regularizing a model in, pure AI in a pure AI setting. Yes, the application's different. Your features might be different. You might be looking at different outcomes, but the technique stays essentially the same, right? And so I'll say the same thing, as I said for the previous question, which is, I think you're 75% prepared for any role. And I think about 25% of it at least comes on the job. Again, and that's varied for me from experience to experience, from domain to domain. It's one of those things where I can give you an answer of 25% you learn on the job, but the reality is it depends on each individual person's experiences, what they've learned in their coursework, and what they're interested in doing and what they end up doing. So, pretty tried to answer a pretty broad question there, but yeah.
Yeah, awesome. No, I completely agree. I think, of course it'll, depend on each person. And I actually like that because I think if that is the case, then it gives, people who are both looking for a job and people overall who are listening to this podcast who might look for jobs in the future, maybe they're just in the early stages of exploring data science right now. But it gives all of us, I think, a little bit more confidence just because, seeing someone like you, like I mentioned, with such diverse, experiences, it sort of makes you think like, okay, maybe all of that is, like just like learning that you have to do on the job. And maybe there's a lot of things to balance, but the fact that 75% of it remains the same and just the application changes, I think that's very insightful. And honestly speaking, it's a sigh of relief. Um, so yeah, thank you for that particular anecdote. Now, I would say going back to the job market type question that we were on earlier, um, I did want to ask because this is a question that I've asked multiple times with varying answers, and I've also, seen other people ask, which is how important would you say grad school is in the general scheme of landing a career versus just directly applying for jobs out of your undergrad degree? And would you say it's super beneficial to consider that pathway for someone, particularly in DS, because I know a lot of positions in DS and ML oriented things are open to people with like PhDs, and there's very few with like, people of just undergraduate degrees who get into those sorts of roles.
Yeah, I think you touched on the last thing you mentioned is kind of something that you touched on, which is what I'm going to start off with, which is, especially in data science, as someone who's been in your shoes and been in the shoes of data science students, the wide variety of data science roles you encounter is, it's a little overwhelming, right? You have data scientists, for example, data scientist roles that say we want a master's with 2 years of experience because it's statistical and modeling oriented, versus you might have a data analyst or data engineering role that requires just a master's or a bachelor's with a couple of years. And then, on the off chance, you might see some positions which are just requiring a bachelor's degree. I think there's nuance to that, right? You a lot of the times job postings don't necessarily dictate or indicate what the role actually looks like. And two is, I think one thing in general, not just for this particular subtopic, I think one thing in general when it comes to recruiting is sometimes the role title doesn't actually matter. And it sounds funny saying that, but a data analyst or a data engineer versus a software engineer title who might be working with Power BI and Tableau and SQL. Well, the reality is those two roles might actually be the same, and different companies might be listing them as different things. And so I think I mean, that's one thing I'd get out of the way in terms of recruiting, like, that I've learned and I've picked up through my experience, through things that I've seen. Now, coming back to your original question about grad school, I think personally, grad school helped me a lot. I'd argue that without grad school, I might not necessarily be in the position that I'm in right now. You can never know because careers have a nonlinear path. I think one aspect is the coursework, right? So fundamentally, I think graduate level courses like probabilistic reasoning or unsupervised learning. I think there are two, very, very important NLP classes. Like I think it's statistical NLP, which is CSE 256, and data-driven text mining, right? And then obviously I've mentioned this before, but my personal favorite and most impactful class, which is LLM systems. I think these courses are really integral, right? They build such a strong academic foundation for what you actually do in an AI oriented role. So, for example, take LLM systems, which is CSE 234. I think that course prepared me for about 75% of my internship work at Marvell and AMD, right? And I think that being said, I think every role has its own nuances that you don't necessarily prepare or study for. For example, my background was in NLP and AI inference primarily. And while that is a significant part of my job right now, I've worked on training out a foundational video model. And nowadays I'm doing more data and agentic AI related things, which aren't necessarily things that I learned or picked up in grad school or at my internships. And so again, I think grad school was important for me, and it helped me a lot. I think the coursework prepared me for a good portion of my internships and my full-time job. But I think, everyone has their own unique journey. I think people's circumstances and people's environments vary, and their skill sets vary. And again, you mentioned this previously. I don't think there's a through line through any of the internships that I've done. I didn't do 3 or 4 software or data science internships back to back to back, right? Um, and so, it's a little tricky to give one, directed answer. I think grad school is extremely helpful for me. It allowed me to deepen my domain knowledge in a subdomain of AI, which is inference and NLP. I think grad school is also an opportunity, broadly speaking, for people to really nail down what domain they want to be in. Let's say you're a data science or computer science major finishing up your undergrad. Well, you might not know if you want to do things like big data, right, with large scale data systems. Or do you want to do something more computer architecture and operating systems oriented? Or do you want to do something with AI and ML? And again, as you know, and as the people watching this know, AI and ML are such a broad term nowadays. So I think grad school has a lot of different objectives or a lot of different, purposes. I think for me, it is extremely beneficial. I think, but that varies on a case to case basis, and it's really what people take from it.
Awesome. Yeah, I really like the fact that you mentioned that, not everyone's, circumstances might be aligned with, going to grad school. Some people might have to get a job right after. Some people, might not even be able to complete their undergraduate degree due to some circumstances. And actually, on that vein, I wanted to, because I know we've mentioned this earlier, but I wanted to ask you also about the overall depth versus breadth and the difference between those two in roles that you've undertaken, roles that you've gone through, because a variety of different people have a variety of different opinions on that. Some people say, of course, that depth, specificity of knowledge in a certain area, in a certain niche of your field is very good, whereas other people say, if you have a broad idea of everything, then it makes you a better problem solver. It makes you more analytical. So I wanted to get your opinion on that as well, because I know we touched on that earlier um, during the grad school question, which was, like, what would you say in your opinion is more important among these two?
Yeah, that's a nuanced question. I think my answer might have even more nuance. Something that I mentioned yesterday to a lot of the students who were listening was, if you look at my resume or my, LinkedIn, you might notice that I started off, I don't even know if I'd list this on my resume anymore, but I had an internship after my freshman year of undergrad that was in firmware engineering, which is actually, working with these different evaluation and testing boards for a semiconductor company and maybe writing some software for them. Following that, my next internship was at Scripps, which was more data analysis and some statistical work. And so there's obviously a disconnect there, right? I think, again, for my case, it's a little different because I started off as a computer science major, transferred into UCSD into data science. And so that experience was mainly like, hey, I know I want to work on data science and AI. This is one foot in the door, right? The following internship was software at AWS on their automatic speech recognition team. And this is where really the depth versus breadth thing kicks in because, that role was purely software development, right? It was in Java and TypeScript, which are traditionally back-end oriented roles. And so I think, it's a really tricky thing, right? On one hand, you do want depth in a specific area because if you're a master of one particular thing, you can always work on that while also branching out. On the other hand, if you're good at, data analytics and data engineering and you know some ML, well, it opens you up to more generalist roles like data scientist, right? So I think again, and it kind of ties into my previous answer for the last question, which is it really depends person to person. Now, I knew that after doing, my Scripps internships, my AWS internship, and while doing my data science degree, there was no through line through these experiences that said, okay, well, this person's really interested in data science and AI. It's this argument of flexible versus scattered, right? On one hand, you could say, well, Amogh, he seems pretty talented. He's able to obviously do the work in these different teams and projects. On the other hand, you can say, well, it just doesn't look like he has like a direction of where he wants his career to take shape or take place. And maybe it's unfocused, maybe he's not sure of what he wants. And so when it comes down to that argument, right, for me specifically, I was aware that this was probably, if it's something I'm feeling, it's definitely something that people can pick up from my resume. And that kind of ties into my last answer, which was that's where grad school kicked in. So I felt like, I had expertise in software, I had some expertise in more data science topics like data analysis, data engineering, some modeling. But I really wanted to deepen my knowledge in the last category, right? So I wanted to dive into AI and ML. And so that's where it helped going to grad school helped me out because in grad school, the way UC San Diego structures it in the CSE department is you have a core depth area where you need to take 4 classes and they're mandated, right? Now you could choose which 4 classes they are, but you take 4 classes in a depth area and there's about 7 or 8 depth areas. And then you take 3 to 4 classes in what they literally call breadth areas, right? It's in the 7 other, domains. You take one course in 3 of them. And then they leave the last 3 courses up to you where you can take any courses you want. And so that turned out to be the perfect, structure for me where coming in, I knew what I wanted to do, but maybe necessarily didn't have the technical depth in the subdomain of AI. And so through grad school, I was able to build, a foundation in my depth area. With my breadth, obviously it's varied, OS or, data systems, whatever it might be. But at the end of the day, grad school helped me keep the breadth while also going extremely deep in one area. And so I think, grad school for me was one option. I think another option is nowadays open coursework online is readily available, right? There's MIT, I think, has been posting courses since, probably a decade ago. I think Stanford releases a lot of their, lectures for free. And so these top institutions are actually allowing you to, gain knowledge free of cost And, you might not necessarily have the in-person experience, but, that's just another solution if you want to dive deeper into one specific area. But again, broadly speaking, I think it's a really, really, nuanced situation that varies from person to person. Some people, I have colleagues and friends who are just simply good at four or five different areas, and they've picked up data scientist roles where they excel in. Whereas I know some people, at my company and, colleagues and ex-colleagues who are just extremely good at one thing. And they're so good at the thing that actually helps them land roles and, they're succeeding in their careers. Now, I don't necessarily consider myself in either of those two categories, but I think, it can be one or the other, or more than likely, it's probably a blend of these things. And so it really varies. It, again, just depends on the situation you're in, the experiences you've had. But yeah.
Yeah, I think that was definitely very insightful just because I've also seen a lot of people say that, they encourage like a T shape sort of where you have an overall knowledge of stuff and then one area is your spike essentially. Um, Also, I would love to encourage everybody who's watching this to, if you're not familiar with MIT OCW, just, go take a look at that because they have essentially every single MIT course up to date with like problem sets, projects, guidelines, solutions to problems. It's amazing. It's really democratized, in my opinion, like you mentioned, the learning process for a lot of different people. Um, so I think that was extremely insightful, and I want to also continue on a very similar vein, which is of course we're talking about depth and breadth, but of course there's also a factor of interest here. So for you, are there any super interesting things that you have learned that would have drastically like improved your experience with data science? And this could be both in your current work, but it could also be connected to something really interesting, something really specific that you learned after doing a project or something that you think would have been super insightful to see during the process of.
Yeah, I think, I'll draw on a personal experience that I was actually reflecting on pretty recently. I mentioned I interned at Amazon as a software engineer on the ASR, so automatic speech recognition and natural language understanding team. And that team was actually, I'd consider two teams, right? One was on the modeling and science side, where they built out this conversational AI models and had the evaluation frameworks. I'd say the other side was the team that wrote the software services. At the time, I was on the latter. And I distinctly remember for that specific summer internship, I had another offer, which was a pure AI role. And the decision-making process for that role is really nuanced, right? On one hand, I strongly wanted to go into AI. On the other hand, there's this opportunity of, doing software, but you're being exposed to AI, while working. And so it's a really tricky thing. It's a really nuanced thing. I think when it comes to your interests, that is one experience where I might not have been working directly on the, AI models, but, just through exposure, right? Of working with that team as well as cross-functionally within AWS, different teams that are working on different research science or applied science oriented projects, you gain some interest. I mentioned I wanted to be doing AI. I had a newfound interest for audio and conversational AI. The more and more in the past, year and a half, ChatGPT and all these different companies have been putting out text models, image models, video models. Obviously, I've drawn from that and gained some interest at the time in text and image. And now I'm at the point where I'm working at a company that's, last year I think in March, Hydra put out a foundational video model. We have the next variation of our foundational video model coming out probably what's today, Thursday, coming out next week. And so that's I was interested in video AI pretty recently. I'd say in the 3 to 6 months before finishing up my grad program. And so at the end of the day, it's exactly what you said. It's about your interest, right? You should do what you want. And if you think, okay, well, I don't have the experience or I don't have the depth of knowledge in that specific domain, you should look at the different resources you have. We mentioned that MIT and Stanford coursework. Coursera obviously has had courses forever. But again, I mentioned at the very beginning of this podcast, nowadays with the speed at which people can develop with Claude or Cursor, or sorry, excuse me, Cursor, Claude, whatever tool you're using, you can go out and actually do a project that interests you. And, I'm sure people listening are saying, well, Amogh, like, I'm interested in audio AI, for example, but these open source models are, 50 gigabytes, 75 gigabytes. And that is true, that it's not always as easy as locally hosting it on your laptop. But I think there's definitely ways around that, right? You can always find some cloud provider who allows you to do this. For example, there's a company called FAL. I think it's called, it's abbreviated to FAL. It's features and labels. But they essentially host a bunch of different models on their platform. And, you can use them. You'd be surprised how it's very surprising how small certain models are. For example, you hear about like, oh, ChatGPT is a couple trillion parameters, and Microsoft, even their small language models, like 5.4, they have hundreds of millions or a couple billion parameters. There's also, I also look at stuff for fun. There's models that you can host. So if you know that you're interested in one particular thing, my advice is to go for it head on. If you're unsure about, I'm interested in a couple different things, well, that's where, classes, that's where your internships especially are going to come in handy. If I'm interested in biotech and deep learning and software, and I get the opportunity to work in two of these domains, maybe I'll figure out, okay, well, actually, I didn't love this domain as much, and I'm so glad I did this because now I know, right? So you have to pair your interests with what your work, what projects you're working on, what courses you do take or go through.
Awesome. Yeah, I think that's actually very important to recognize that, it's quite difficult to figure out what interests are, especially for people who are like still in undergrad and might not have like the full gamut of experiences that comes with, doing lots of projects and working at different places. And actually tying on to that, let's say hypothetically there is a student who is interested in something and they get an internship or something in that field, but it turns out that they don't like it. Would you say that it is possible to still derive lots of meaningful benefit from that experience? Moving on to like a totally different subfield, maybe they can draw on those experiences to do something there. And I asked this in particular because, again, like I mentioned, you have a very diverse set of experiences. So I was wondering if, there are some things you learned from, maybe even totally different, unrelated fields that you have found, come together in really interesting ways that have helped you, despite the fact that you don't work in that field anymore.
Have an experience in an internship that maybe necessarily turns them off or turns them away from this interest. Well, I think there's two aspects to that. One is, that's just a sole experience, right? And again, I've done internships. I'll be the first person to tell you internships are not this golden seamless experience, right? Sometimes you do fall into situations where, you're put on a team and the team itself is in a state of flux about their project, about, the head count, whatever it might be. And so in that situation, you need to understand that, hey, maybe this is just one bad example. There might be one bad egg in that carton. And so that's one thing to recognize. But also, if it turns out that, hey, you actually did go through this experience and didn't really end up liking the field and you want to pivot somewhere, well, I think, I think that's where people's environments and situations come in. And it's like, okay, well, let's say you're in year three and you realize of your data science undergrad and you realize, hey, maybe I don't really like data science. I like more, something biotech oriented or something more philosophy oriented. Well, the good news is nowadays, right, there's an application for data science everywhere. So I might say, okay, well, if you're interested in something like philosophy and data science, maybe the social science, domain or the social computing domain is something that's interesting to you. Maybe anthropology might be interesting. They're using computing techniques in that too. Or if you're interested in biotech and you have a data science background, something like cognitive science is the perfect route for you, which UCSD does have a major for. Again, I use UCSD as an example, but broadly speaking, it's not necessarily, you're not going from chemistry to computer science, maybe. If you are, that's also fine. But usually people who pivot aren't going from one field to a completely different one. It's usually, computer science to cognitive science. So it's just, you need to be aware of the circumstances of you gone through, and you need to be, you know, cognizant of what you're pivoting into and what you're pivoting from. And I think that's the best advice I could give to anyone.
Yeah, I think that's also a really good Because that's also a really good thing to point out because earlier, as I mentioned, not everyone is sure of what they want to do. Maybe it's just a broad area that you're interested in, but it might be that a certain subfield of that area is actually what interests you. But again, what you mentioned, I relate to heavily because, like I mentioned, I knew I wanted to do something mathematical. And again, I am a first year, so of course I haven't, like figured it out in its entirety myself yet. But
Yeah.
I knew I wanted to do something mathematical, and the good thing about a field like math, similar to data science, like what you mentioned, is that it's essentially universally applicable. Just because everywhere you go, there's going to be data, and there's going to be some analysis you have to do on that
Yep.
data.
Yep.
And those techniques are, like you mentioned, with machine learning and regularization, be adapted specifically to what data set you're
Yep.
working on. But yeah, approximately 10 minutes left, which is actually pretty good because I want to shift now to talking about a very broad question, um, which I hope we can, it's quite substantive, I think, and it's an interesting one, which is the BS or ML from, big data to large language models. So these have had varied levels of success, of course. I remember clearly, like maybe it was 10 years ago, maybe a little bit less than that. A lot of people were saying, big data is the next thing, and stuff like that. But again, like I mentioned, these have had varied levels of success. So what interesting or underrepresented subfields do you think current students should be aware about that might materialize into the next big thing?
Yeah.
And how can students best position themselves in order to gain experience that is necessary for such roles? And again, feel free to go as broad or as specific as you want.
Yeah. Yeah. I mean, first off, I'll just say that, this big data trend that was there about a decade ago, I can make the argument that while it's not positioned as big data, I can make the argument that that trend still holds because you see nowadays all the frontier models and frontier AI labs, they're coming out and saying, yeah, we've applied all these machine learning techniques, and the reality is we just had better data than that company, and it ended up being data quality. But that's a whole separate topic. I digress. Yeah, I think, and honestly, amazing question. I think, frankly, I could take about an hour to talk about this easily. I think I'll say this, like, in the past couple of years, ChatGPT came out, what, November 2022, I believe. And I think that's been the hottest topic or trend. I think in the past 3 or 4 years, there's been a handful of topics that have dominated, I think, the tech sector, for example. I think the first being, training hardware, right? So a company named NVIDIA, which people might have heard of, they've dominated that sector with their GPUs and their training hardware. I think the second trend that I've noticed, which is really relevant nowadays, is domain-specific AI, right? So you think of companies like Cursor for, code development, or Harvey, which is fairly new, but they're doing legal AI, or a company called 11 Labs, which is doing audio AI. So I think domain-specific AI is something that's been trending for the past couple of years and is extremely relevant. And I think the third thing that I've noticed is, it's something abstract, but it's this dominant role of UX, right? User experience products. If you think about Cursor, think about ChatGPT, right? These ideas like using Sublime, which is an IDE, and then Copilot, or just having a locally hosted trained LLM and then querying it. Cursor and ChatGPT have much, much, much more seamless user experiences. So I think these are like trends that I've noticed in the past. Now, I think within AI, data science, ML, there's a lot of different trends that I see moving forward. I think there's three big ones, two or three big ones. I'd say the first is this idea of AI inference, right? So obviously training models is really important. And how good your model is extremely important. I'm not going to say it's not. But I think with models and training compute, what's happening nowadays is these things are being democratized. For example, with neoclouds, which let you rent hardware by the hour, or platforms like I mentioned, like Features and Labels or FAL, which let you utilize a wide variety of models. I think because of this, because it's being democratized, the focus is going to shift onto concept like AI inference, which essentially is driving how fast your models respond to your queries and how fast can you get reliable answers. When you ask ChatGPT a question, it thinks, it spits out an answer. So your time to your first token and how many tokens per second does it generate? These are both fundamental AI inference concepts. And so AI inference in and of itself is comprised of two things, right? You have your software, for example, frameworks like VLLM, which is helping efficiently do inference. and then AI inference hardware. So companies like Cerebras, companies like D-Matrix AI, which is, a newer startup. And NVIDIA has already, proven the point that I've made by acquiring a company called Grok, I think end of last year, which is an AI inference hardware provider. And so I think the first big trend that I'm noticing is AI inference, specifically, on the hardware and software side. I think the second broader trend that I think will take a little longer to develop is this idea of agents and autonomy and agentic AI, right? I think 2025 was a year where a lot of these research labs and a lot of these companies did a lot of R&D surrounding agents and agentic AI. I think 2026 is going to be about enterprises and developers in general finding ways to smoothen their process and vertically integrate their products with agents and agentic AI. With respect to autonomy, I think companies like Tesla, which has fully self-driving, technology, a company called Figure, which is doing, humanoids, and I think Tesla's, technically delving into this realm as well. But I think these companies are going to start vertically integrating their products with agents and agentic AI, and then on the other side, more hardware oriented, autonomy when it comes to that. And I think, admittedly, that's also one aspect of what we're focusing on at Hydra, right? I mentioned there's a creative studio that we have, and we're literally currently working on integrating AI agents and agentic AI within this to improve user experience and to make our product better. I think those are the big two trends. I think, coming off of agents and autonomy is physical AI. I think personally, more advanced robotics like that is a 2027 and onwards problem. But yeah, I think these two trends, AI inference both in hardware and software, and then agentic AI and just autonomy across the board. I think those are the two huge trends we're going to see this year, or they're going to be the next big thing. I think when it comes to students, as an undergrad or even a graduate student, it's very daunting, right? You ask the question, well, agentic AI, it's this abstract concept that we're not necessarily learning. I might stand corrected. UCSD might be doing that. I would not be surprised. But it is very difficult, right? It's not readily available to learn these different things. I think, one part of learning is implementation and, practical applications. I think the other part of it is reading. And, this is the third time I'm going to allude to it, but this MIT open coursework, Stanford has these courses. I think YouTube, strangely enough, is being flooded with, just hobbyists who are developing random things, AI agents, autonomous AI. I mean, industry legends, Andrej Karpathy, right? He's putting up tutorials about, Nano GPT and Mini GPT. I think the internet has become such a great source for learning, and you can learn cutting edge things off of your laptop. Again, I'm not saying that you can learn everything off of your laptop. I understand that if you want to train, a large AI model, your laptop, your MacBook Pro won't be enough. But I think, when it comes to these specific trends, writing AI inference software, the code for it is not something that, you're compute restricted or you're bound by. I think, that course CSE 234, I did completely on my MacBook Air, right? So it's not something that I'm restricted by or bound by. I think to position yourselves in order to be, successful and gain the experience for these roles, you need to, I think it just starts with projects, and you need to be a self-starter, right? You need to have that drive or initiative of, okay, well, this, AI inference, this sounds like a really cool topic. And if you start reading about it, you'll notice, okay, well, actually, even within software, there's three or four different components. Let me just start with the first one. And so you do need to, it does become and boil down to just reading, and it's the method of how you're learning. And I think that's the best advice I could give someone who's interested in these more abstract or complex topics, which is don't necessarily jump to how do I deploy an AI agent locally. I'd say start with the basics of, okay, well, AI agents are a series of tool calls. But it's not just a simple stack of tool calls. There's certain reasoning that needs to happen. There's certain evaluations that you need to do, and there's certain thought processes that you need to actually implement. So I think starting with the basics, starting with the building blocks of these very advanced topics, and of course, you need to do a lot of reading and learning. So a very long-winded answer to, your trends question, but I think that's the reality. I don't think there's anything that's not nuanced nowadays. Yeah.
What an awesome note to end on. Learning. I really do agree with that. And again, I would love to encourage people to take a look at, it just came to my mind while you were mentioning OCW, Coursera and Udemy, both of those. I believe you mentioned Coursera earlier, but Coursera
Yep.
also has a free tier, which, you can just learn without getting their certificates. So that MIT OCW, and of course, like you mentioned, hobbyists. What an awesome note to end on, learning. I really do agree with that. And again, I would love to encourage people to take a look at, it just came to my mind while you were mentioning OCW, Coursera and Udemy, both of those. I believe you mentioned Coursera earlier, but Coursera
Yep.
also has a free tier, which, you can just learn without getting their certificates. So that MIT OCW, and of course, like you mentioned, hobbyists and YouTube, all awesome sources to learn. And I don't want to take up more of your time, but thank you so much for this awesome interview. And yeah, I hope to the people watching that this will be beneficial.
Yeah, no, thank you so much for having me. And one last thing that I'll note is a lot of these things, I've said, it might sound like, well, Mo, you're saying this now. I just want you guys to know that I've literally been in your shoes, right? I've been an undergrad at UCSD studying data science. I personally have done Coursera certificates in deep learning. I think two or three of them. I've done, a Stanford course. I've done this MIT open coursework. I've done internships in diverse domains. I've done a bunch of coursework. Again, in diverse domains. I've applied, as an undergrad, I think I applied to about 1,000 full-time roles. Ended up going to grad school, which is a whole separate topic. But I think, I think that I hope you guys take away is that there's not one linear path, right? And I keep emphasizing this. You should do what you want to do, right? And if it is like, hey, I want to do data science and AI and ML, well, the good news is it's a very, very broad domain. And I think there's a lot of scope for you to carve out a niche or just, deal with the nuances of the field. And so, yeah, thanks for having me. It's always a pleasure to, talk to some students and talk to, UCSD students, especially as I go Tritons. But yeah, thanks for having me.